We're excited to talk about hydrogen today. I think most of us use electricity in our everyday life, but not all of us use hydrogen, and yet we're hearing about it a lot, especially as we talk about climate change, renewable energies, and kind of what the fuel of the futures will look like. So I'm really excited to have folks today join us to talk about these things and help to educate us and fill in some of those gaps in our knowledge. Tomi, Taylor, and Ryan are our speakers today, which is going to make, I think, for a really robust panel. We're going to start off with Tomi Riley, and it's really wonderful, Tomi, to have you here. She's joined us from Southern California, so it's one of the reasons that having these meetings online can be really great. She's also the manager for government relations for Air Products and brings that role more than 20 years of communications, government affairs, and community outreach experience. Many of you have had the opportunity to get to work with Tomi over the years. She's worked in both the public and private sector. Prior to joining Air Products, she held numerous senior positions, including director of the Bay Area Government Relations for the California Alliance for Jobs, a labor management organization focused on water and transportation project funding and affordable housing. She was vice president in California for the PBN Company, a strategic communications firm, and later started her own public affairs firm, bringing on two partners to form Strategy Com. I hope I pronounced that right, Tomi, LLC, where she was the managing partner. It's really wonderful to have you here, Tomi, and we're excited to hear from you. I will introduce all of our speakers individually. So we're going to start off with Tomi's presentation, and then we'll transition to Taylor and then Ryan.
Thank you, Lindsay and Gary, and hello, good morning to all the East Bay Leadership Water, Environment, and Energy Task Force. It's so wonderful to see some good friends, longtime friends here. And yeah, I see you, Amy. It's just great to see your face. Anyway, so thanks all, and I look forward to telling you a little bit about what I know about hydrogen and a little bit about Air Products, just so you know where the information's coming from. I'm going to share my screen here. Give me a minute. Are you seeing my screen?
Yes, we are.
Yep.
Okay, so welcome to a world fueled by hydrogen. Just before I jump into the presentation, I think it would be helpful for you to know who Air Products is. So forgive me for a 2-minute commercial, and just provide you with a little background on where I get this information and who it's coming from. So Air Products is the largest producer of hydrogen in the world. We're also the largest producer of hydrogen in California. In California, we own and operate 10 hydrogen plants, 30 miles of pipeline, and 6 hydrogen refueling stations. Worldwide, we have committed 15 billion to the clean energy transition. So we're kind of betting the farm on hydrogen here. We're a Fortune 300 company in 50 countries with almost 22,000 employees now. So we've been in the business a long time, and we're not an unfamiliar name to some, although we have traditionally worked from behind the fence line and not been too far out. But I think with the East Bay leadership team, we've been around. So why hydrogen is what I'd like to talk about. I was asked specifically to talk a little bit about hydrogen production. I'll talk about the California market for hydrogen, another quick commercial about Air Products, and then briefly some predictions about the future. So why hydrogen? Really, the climate crisis is real. And for the purposes of this presentation, we will need to assume that climate change is real. I think most of the folks in this group understand that CO2 concentrations have risen by more than 30% since the Industrial Revolution due to burning of fossil fuels and deforestation. You'll see in these two graphs that carbon dioxide concentrations have significantly increased, and along with that, temperatures. And we're feeling that a little painfully right now. California is particularly noticeable for these effects. We have a whole new season. When I was living up in Grass Valley, I was, painfully aware of the new season called fire season. It's become a part of our lexicon. Droughts, periods of rain, local air quality is diminished. So climate change really threatens our economic growth, food security, agriculture, migration, and on and on. Where do we see hydrogen? I want to first put it in context that we believe at Air Products that hydrogen and battery electric are complementary ways to decarbonize. We do see those as the two major energy sources in the future. But when will one be used over another? We believe hydrogen will be preferable when distance, weight, or higher temperatures are needed as an energy source. We kind of predict that the battery electric will tend to be used for light duty cars, buses on shorter routes, perhaps, light and medium duty trucks, light industries, heating and cooling. We see that's where electric will go. But the piece of the pie that hydrogen will get, again, focused on the distance, weight, and higher temperatures, those buses on longer routes or more challenging routes, medium and heavy duty trucks. Port equipment is a big opportunity area for hydrogen, heavy industries. And yes, as Gary mentioned, in the future, a little farther down the road, trains, planes, and ships will be potentially moving on hydrogen. Hydrogen's also a storage opportunity for renewable energy. So when the wind's not blowing and the sun's not shining, you might have backup hydrogen storage to feed the grid. I will stop and do a quick caveat. Many of you may know we do have a number of hydrogen refueling stations, and they're all light duty. So why would I say light duty cars are going to battery electric? Our best guess at this point is that about 70% of the light duty cars will go battery electric, and maybe 30% will go hydrogen. Again, a best guess. And why is that? Well, most of our behavior is we go home at night, we go to sleep, we can plug in. And so light duty cars make sense with that lifestyle. But what about those folks who can't go home and plug in? They live in apartments or condominiums and don't have garages, or may not have access to charging. Those folks may need to go hydrogen. And then there's just plain choice. We like to have choice in our fuels. And we believe that there will be folks who prefer the pull up to a station, fill up in 10 minutes and go on their way. So our best guess when it all shakes out, 10 years from now or so, it'll be about 70-30. The case for hydrogen, that's what we're talking about now. Why hydrogen? Well, industry and research indicates that the world lithium and cobalt resources will not be sufficient to fully electrify. When you look at all of the sectors that will have to transition during the clean energy transition, if everything went to electric, our power grid would not be able to hold the demand. To achieve 100% renewable, seasonality of wind and solar must be addressed. Wind doesn't always blow, sun doesn't always shine, as I said, and batteries are inefficient for long duration energy storage. So world experts really do agree that hydrogen must be a part of the equation. So many people might remember the start of hydrogen with the NASA spacecraft. Air Products was providing hydrogen to NASA back then, and we are providing hydrogen to NASA today. But hydrogen is the smallest element, number 1 on the periodic table. H2 is the lightest element in the atmosphere. And it's a very known quantity in terms of its use for ammonia fertilizer and other industrial works, most notably in California to help desulfurize gasoline. I mentioned that we have about 10 hydrogen plants. We have 10 hydrogen plants in California. All but 2 of them are on site at refineries. So we work with the refineries to provide hydrogen, and that allows them to do the work to clean up gasoline. That was a big market for us with the cleaner burning gasolines. And so that's when we expanded to 10 hydrogen plants here in California. Hydrogen future. I think I've kind of touched on this, but we really see a market for ports and port handling equipment. Again, weight comes into play and potentially amount of uptime they need. Long haul trucks we see as the next segment. If we're using hydrogen today in light duty cars and in buses, as we'll hear from our one of our next speakers, long haul trucks is the next to convert, and that's a big market that we're looking at. Further down the line, we will have trains, ships, and planes, and possibly energy production. You can replace hydrogen with natural gas. Replace natural gas with hydrogen, sorry. The caveat I will offer here is with ships, there's some folks that believe that a future bunkering fuel will be ammonia versus hydrogen. And for those of you who go back to your high school chemistry, ammonia is NH3, hydrogen's H2. Ammonia is very dense in hydrogen. So there's a guess that ships may be running on ammonia as their zero emissions fuel in the future. Hydrogen production, that's what I was asked to cover this morning. I'm not sure how deep everybody is into hydrogen here, so I'm going to start from the beginning. The world is moving towards a lower carbon hydrogen production. So today you'll find that 95% of the hydrogen produced in the world and in California is steam methane reforming. That's called gray hydrogen. I'm using these colors really just for simplicity. In fact, my company is a little averse to using the colors because we think carbon intensity, real carbon intensity is probably a better way to look at hydrogen. But for the purposes of today, and the reality is a lot of policymakers who are just still becoming familiar with hydrogen tend to use the color codes as well. So gray hydrogen, the catch here is that you use natural gas and water to produce hydrogen. So while the fuel that comes out the other end is a zero emissions fuel for use in AC transit buses or your Toyota Mirai that you may drive, the production process itself is not zero emissions. We use a fossil fuel, natural gas, to produce that hydrogen. So production is not zero emissions. End result, fuel is zero emissions. Blue hydrogen is similar. Excuse me. It's the same process in the beginning. It's all SMR driven, steam methane reforming. It's gray hydrogen production, but you'll see on this graph that CO2 is captured rather than being released to the environment. So it gets the color code of blue. Again, the production process itself involves a fossil fuel, but the emissions that we worry about are captured. They can be captured and sequestered. They call it CCS, carbon capture and sequestered, into a geological formation. They could be captured into a product such as cement, where it's sequestered in the product. So that's blue hydrogen. Green hydrogen is the sexy hydrogen in California today. That's what everybody wants. You know, the caveat before I get into green hydrogen is, you know, the world, including the state, including the environmental community, has come to grips with the fact that it's going to take until 2045 to green the grid, the electrical grid. You know, some days it's getting close, but many days we're relying on oil and gas and other fossil fuels to energize the grid. But there's now an acceptance that we have till 2045 to make sure that grid gets to green. Well, people aren't that patient when it comes to hydrogen. They want us to move from gray hydrogen to green hydrogen overnight. And I guess I should place that on the backs of some of the environmental community would like to see. We'll say that gray hydrogen is all you have in California today, and it's bad, and we shouldn't have it. Well, if you want to reduce 50% of your emissions from transportation today, we may have to go with gray hydrogen while we are evolving the molecule. So just like the grid is evolving, the molecule will go from gray over time to green. So that's electrolysis of water with renewable energy. The renewable energy would be wind, solar, hydropower, whatever we'll classify as renewable to make that green hydrogen. It's CO2 free, but it does require new construction and reliable, most important, reliable, low cost renewable energy. So those are things that we're working on in this evolving market is to get there. So we'll see if we can get there by 2045 to get all the hydrogen produced in the state by 2045. I'm not sure if we will, but we're aiming to do that. So again, gray is about 95% of what's produced in the world today. It is steam methane reforming, which uses natural gas and uses very high heats, as high as 2000 degrees Fahrenheit, in the presence of steam, and it results in the breakup of the methane molecules to form both carbon monoxide and hydrogen. Carbon monoxide gas can then be repassed over the steam, and we knock out a little bit more hydrogen from the process. So the upside of gray hydrogen is it's producing zero emissions fuel. Those cars running around on the freeway and those AC transit buses delivering folks to their stop are zero emissions out the tailpipe. But the downside is the byproducts are CO2, and it's not yet carbon neutral. It takes about 1 ton of hydrogen produced will also produce about 9 to 12 tons of CO2, a greenhouse gas that hopefully, as we move into the future, will be captured and not release the environment. So the two most prominent forms of production are gray hydrogen today and the future, which is green hydrogen. Electrolysis consists of using renewable electricity, typically from solar or wind. Hydropower might be an option to split water into hydrogen and oxygen. It can be produced at a much lower temperature, less than 200 degrees Fahrenheit. It's about 70 to 80% efficient today, and by 2030 we expect it to be a little higher. There's different types of electrolytic cells, solid oxide, polymers, and alkaline cells that are used. Some are more expensive than others, some are cheaper. Efficiency is affected by cost. So that's kind of your primer on production of hydrogen. If you're not talking about hydrogen on a daily basis, knowing gray, blue, and green will probably get you where you want. There is a whole rainbow of colors. I think it's pink is nuclear. So nuclear, again, being a zero greenhouse gas power source, can produce hydrogen as well, giving you a green hydrogen. There's a whole color code of rainbow. I don't know if I know all of them. So I'm going to move on a little bit to California. Driving the market, Air Products is all in California. And why is that? Let's take a quick step back and look at decarbonizing California. What is it going to take to get to 2045 or 2050 and be a fully green state? If you look at the pie chart here, the transportation sector with 38% of the greenhouse gas emissions is the biggest target. It's a market for Air Products. We're moving towards that. Cars and buses running on it today. And the future, heavy duty trucks, potentially power plants, heavy duty equipment, ports being a big target. Following that, trains, ships, and planes. Again, our target is transportation and industrial in terms of greening and decarbonizing. Everything else is 11% or less. So those are our two big targets for decarbonizing California. This chart's a little busy, and if you're not seeing it real clearly, which I apologize, what I'm doing across the top of the chart is looking at different years from 2022 to 2050, and how is California driving that market? Well, by 2035, they're saying that all new vehicle sales will be 100% zero emissions vehicles. That's the first line cars on the down the left side. They're saying that all bus fleets will be converted by 2040. And all drayage trucks will be converted by 2035. All truck fleets will be converted by 2045. As we know, many of us know, the power grid is expected to be 100% zero carbon and renewable electricity by 2045. We'll see if we can get there. And carbon neutrality in the state by 2045. Statewide greenhouse gas emissions reduced by 80% below 1990 levels. So California is driving this market. Many companies are saying it's too fast, too much, too fast. We're really enjoying the market and finding that it will create a great market for our product. So what's going to be needed? This graph shows, this chart shows really only the conversion of transportation. How much hydrogen will we need simply to convert all the vehicles, whether that's light duty, heavy duty buses, drayage, whatever. How much will we need just to convert the mobility market? So today we produce about 3,750 tons per day in California. Gray hydrogen. Where do we need to get? We need to get to 17,200 tons per day. So we're, 14 thousand tons per day short. So this is why we now have the run to hydrogen. I say that there was a gold rush here in California at one time, and then there was the green rush with cannabis. Now there's a hydrogen rush. So it will be interesting to watch. I would offer that for those of us who are going to be around till 2035, 2045, it's going to be an interesting ride and a lot of fun to watch how this plays out. So Air Products, the company I work for, is betting big on hydrogen. We've got green hydrogen production planned or underway in Arizona, New York, and Texas. And we're doing major blue hydrogen projects in Alberta, Canada, and Louisiana. So while we have a long way to go to get to 17,000 tons per day of hydrogen in California, the effort to produce that low carbon hydrogen is underway. This is just what Air Products is doing. And what's not shown here that I'll add is that we aspire to bring about $2 billion in new projects to California. We are a part of the ARCHES consortium, and if you're not familiar with ARCHES, it's a group that came together to submit a single application to the Department of Energy, who's offering up about $8 billion to incentivize hydrogen hubs across the US. So we're one of a number of companies that came together to submit through the state of California. It's driven by Office of the UC President, along with GoBiz in the state, to bring everyone together and submit one application so we weren't competing and dividing up our options in the state. We're excited to be part of that process, and again have about $2 billion we hope to spend in California to move the clean energy transition. And I'm wrapping up here, Lindsay. So what's gonna happen? So by 2030, what do we expect to see? That's really not that far from now, 7 years. You'll see a great deal more fueling stations dedicated to hydrogen. We own and operate 6. We have 25 that I can count and I know of, either in land development or permitting right now in the state. And that's just us. There's a lot of people out there doing the same thing we are. So you're going to see a whole lot more hydrogen refueling stations popping up. Trucks, you'll see more fleets adopting zero emissions fuel cell technology. Air Products has a fleet of 2,000, and we are converting. We've put in an order to convert all of our 2,000 trucks to hydrogen. We've got 2 off the floor running around Southern California right now delivering hydrogen. The trucks are not being produced on assembly line yet. So we're hoping that 2,000 truck order will start to push some of the companies to an assembly line so we can get more trucks out the door running on zero emissions. And again, the molecule, you'll see it produce more hydrogen produced locally and regionally. And actually, I will offer that as we do today, we import a significant percentage of our energy, whether that's our natural gas or other fuels. We'll continue to see that in the future. California just doesn't have enough land and water to produce all of the renewable electricity that we need to produce hydrogen. So in addition to in-state production, which Air Products does have planned, you'll see potentially the importation of hydrogen, green hydrogen from other places. I didn't mention that the $2 billion we'd like to bring to California is all green energy, green hydrogen. So we're excited to be one of the first movers to get significant quantities of green hydrogen into the state. And I'll end on that with a view of our hydrogen refueling station. Lindsay, do you want, or Gary, do you want questions now or after?
Thank you, Tomi, and thank you for that wonderful presentation. I feel like I learned a lot in a short period of time, which is not always an easy goal to achieve. So thank you. I do think we'll do a few questions now, but there were a few that I think everyone might want to kind of chime in on. So I might hold some of the questions until towards the end so that all of our presenters can chime in on them. But some of them were kind of Air Products specific. So I'm going to take a few minutes to ask those, if that's all right with you, Tomi.
Sure.
One of them was, does Air Products produce any blue hydrogen today?
We are in construction on blue hydrogen projects in Louisiana and Alberta. It's not in, startup has not happened.
Okay. And this is a question that I think might kind of apply to all of our speakers, but I want to ask you, since you're coming from the perspective of a company who's kind of contemplating this. And that's the question from Bob Whitley, which is about water. Can the water supply be a lower quality than that for domestic drinking or agricultural demand? And what is the efficiency for conversion of water to hydrogen?
Yeah, they're working on that right now. I think that's a great question. We're excited that our plants, they're locally in Contra Costa, are at Avon and PBF refinery on Martinez, close to some of the recycled water agencies. So yes and no. So today, is it happening? No, but I will offer that our hydrogen plant, our gray hydrogen plant located down in Wilmington, California, has signed a commitment with the Department of Water and Power in Los Angeles to convert that hydrogen plant to purely using recycled water. So it's while not happening today, I think it's in the near future. I've also seen some research being done on salt water. My best guess today is recycled water is going to be the next step. I'm not sure when we'll get to salt water as a potential use. There's a whole lot more complexity to that.
Wonderful. And then we did have a question that had to do with converting hydrogen for basically current gas engines. I'm actually going to save that question until the end because I think that's something that everyone could reflect on a little bit. And we did have some questions about biogas, and I actually think Raven SR is here, which is a project that somewhat relates to that. So that's another question I'm actually going to save just so that everyone can kind of chime in on their understanding of biogas, just recognizing that's not specifically what Air Products is looking at. Does that sound okay with you, Tomi?
Sure. I will offer that we do have one facility. Air Products has invested about $2.5 billion into a sustainable aviation fuel facility in Paramount. And we're looking to convert our gray hydrogen facility that's being built there to a biogas driven plant. So that's one example.
Okay, well, that's an interesting project, and hopefully we can have some time at the end of this meeting to talk a little bit more about that and other projects, including, like I mentioned, that there's one local. Thank you so much, Tom,
Yeah.
for being here. If there was any,
Marathon's doing it, the sustainable aviation fuel, I think, too.
they are, yeah. There's a lot of exciting things happening here, and it's really wonderful to have this space because we've been able to bring in folks to tell us a little bit about it, and looking forward to continuing to follow it and having more presentations in the future. So. Okay, well, we are going to transition. If I did miss your question, I apologize. Please feel free to put that back in the chat or just ping me, and I'll try my best to bring it up after our next presenter. Our next presenter.
Cindy, I think you muted yourself.
Yep, you're on mute.
Yeah, as I went to the other window, it muted me. Apologies. Thank you. Okay, Taylor Huff is VP of Hydrogen Marketing for H-Cycle, which is a renewable hydrogen producer headquartered in Concord. He's focused on developing H-Cycle's facility in Pittsburgh. Taylor started his career with BP developing international energy projects, before transitioning to focus on advanced renewable hydrogen as a clean energy fuel to reduce climate change. He holds an MS from engineering from Stanford University and an MBA from Northwestern's Kellogg School of Management. Thank you for joining us, Taylor.
Yeah, thanks, Lindy. We definitely appreciate the invitation. As you mentioned, we're headquartered in Concord, much smaller office than Air Products, but our first two projects are in the East Bay, and that's not by coincidence. We see a lot of opportunity for the East Bay to really be a leading hub in Northern California for this emerging renewable hydrogen ecosystem. Let me share my screen here and have some slides to show. Let's see.
We're seeing.
Okay, perfect. So who is H-Cycle? We're a company focused on developing, owning, and operating renewable hydrogen production facilities that actually use an organic waste feedstock. So a different form of green hydrogen than what Tomi talked about. We have a partnership with a technology provider who has built facilities using this technology at increasing larger scale. So we believe that the technology is proven, and we're focused on developing medium scale projects throughout the state to produce renewable hydrogen. Since we're using an organic waste feedstock, we really have an interaction with two industries. It's not often known, but landfills are actually a significant contributor to greenhouse gas emissions. And that's because organic materials decompose in landfills to produce methane. It's on the order of 3% of global GHG. Sounds small, but it's literally on the gigaton scale. California is well aware of this, and a few years ago passed SB 1383, which is really first of its kind in the country. It's now been sort of adopted, you could say, by Washington, and some other states are looking at it, but really they're copy and pasting the California law and approving it. But what that law does is it mandates increasing diversion of organic materials from landfills over time. And this is not just food waste and yard waste, right? So waste systems that have a green bin to collect source separated food waste or yard waste, that's ideal feedstock for composting or anaerobic digestion. It needs to be very clean. It can't have a lot of plastic films or waxy cardboards, plastic silverware. It really needs to be quite clean. But there's a good solution for those streams. But there's a lot of other trash. There's a lot of other waste that has organic matter that decomposes into methane. So this is things like papers, cardboard, construction demolition debris, wood, any sort of wood products. There's a lot of waste that it can't easily be composted or anaerobically digested. It's either too mixed or simply not a fit for those processes. It's going to landfills today. It's decomposing and producing methane. California knows this, and that's really what SB 1383 is meant to address. And that's where we fit in. We're focused on taking those types of mixed dirty organic streams and producing renewable hydrogen from them. We're talking a lot about hydrogen here. There's a variety of different markets and uses for it. But I think for the East Bay, it's quite clear that heavy duty trucks in the Port of Oakland, drayage trucks that are operating out of distributions and centers in Contra Costa County, that's a clear market for hydrogen. Transit buses, albeit a significantly smaller market than semi trucks, that's a great early moving market, and good to see AC Transit here. But then also what's not talked about so often is the 4 refineries in the East Bay, 2 of which are now converting to produce renewable fuels. They're very large consumers of hydrogen, so there's an immediate replacement of that fossil-based hydrogen with a lower carbon intensity green feedstock, green product. So this slide describes with cartoons the 3 units of our projects. So what our process is, it's a non-combustion thermal conversion process, meaning we're not combustion, we're not incineration, we're not burning trash. There's not combustion happening, but we are using high temperature to convert the organic material. Organic material has, really by definition, carbon and hydrogen atoms. We're converting the organic material into a synthesis gas, which is very rich in hydrogen, from which we're extracting and purifying out the hydrogen. CalRecycle calls a facility like ours an engineered MSW conversion facility. And what that means is we're using an engineered MSW. We're contracting with waste haulers throughout the Bay Area to receive streams that have already been collected curbside. They've already gone to a transfer station or material recovery facility. There's been a level of recycling, processing, pulling out green bed materials. And the status quo is these materials will be loaded up into trucks, into transfer trucks, and sent to landfill. Instead, the rerouting would be to our facilities. At our facilities, we do another level of waste processing, some additional removal of any remaining remaining plastics and inert materials, glass and metals. Not a perfect processing efficiency, but sufficient that our machine can take it. There's also a drying and a shredding process to create a more uniform feedstock. So roughly similar size. We have a moisture band that we want to hit. So the waste is received, it's quite mixed. We take it through level processing. And then the engineered MSW feedstock is fed into a conversion unit. That's powered predominantly by electricity. And compared to electrolysis, we use 4 times less electricity. So a lot of the challenges Tomi was talking about with the grid needing to green, which will take years to do, the need for large scale renewables to be built. We don't have that large electricity demand. We have a much more nominal electricity demand because the source of the hydrogen atoms, it's organic waste. And organic waste is much more volatile than water. It's quite difficult to split water. It's much easier to split organic waste. And then after we've converted the feedstock into synthesis gas, then we purify and extract the hydrogen, which will be compressed into tube trailers. It's how small scale volumes of hydrogen are moved today, compressed into tube trailers, and then sent to various customers who will all really be in some way connected to the transportation market. So waste trucks come in, process the waste, convert it to hydrogen-rich gas, purify the hydrogen, and then compress it for product delivery. We do have a vitrified slag byproduct, which is basically any remaining glass or metal. With high temperature, it melts and then it resolidifies as a slag. It's a non-leachable material it's been tested, and there's clear California and EPA guidelines on materials like this and leachability. It could be sent to landfill for disposal, but we're seeking to get it qualified by Caltrans as a roadbed material, or it could be some concrete aggregate markets. But that could be at least a beneficial, revenue neutral at best, market for this byproduct of ours. It's the volumes produced are not particularly significant, so even if it does go to landfill, there's still a large amount of waste reduction. It's not organic material, so it would not decompose into methane. So given that we're operating both in the waste industry and all these different arms of renewable hydrogen, there's a lot of regulatory objectives that we can help address. SB 1383 goals to divert organic waste from landfills. We're very much tied in with that. There's quite a few legacy assembly bills as well that sort of set the table for 1383 and really the true first mandates with teeth in the states. And then for hydrogen, since it interacts with both the transportation market, but then also with the fuel refining market, there's interactions with both the low carbon fuel standard. That's an existing program. California, once again, a leader with the LCFS program now all up and down the West Coast, Oregon, Washington, British Columbia. It's been adopted. Other states like New York are looking at it, but the low carbon fuel standard provides a clear green premium for our product. For any green hydrogen product, any low carbon hydrogen product, the low carbon fuel standard, it's clear monetary value to use renewable hydrogen, whether that's directly dispensed into vehicles or whether that's in a fuel refining process. The low carbon fuel standard is a great boost. And then much more recent, the Advanced Clean Fleets and the Advanced Clean Truck Rule mandating heavy duty trucks to go to zero emission, whether that's hydrogen or battery electric. That's quite powerful as well. And it's more of a stick approach, but it is forcing fleets, all types of fleets, public and private, all types of fleets will need to transition. There's various different dates for either public, private, drayage trucks, normal fleets, quote unquote. There's a lot of different dates, but that's a clear mandate to transition to ZEVs. And then there's carrots like the low carbon fuel standard and programs like HFIP to incentivize the purchase of the trucks and encourage the use of low carbon fuel. So there's a nice balance in California, both carrots and sticks that are really pushing the transportation market, the heavy duty transportation market, to hydrogen. There will be some battery electric, of course, but as Tomi mentioned, there's clear cases where hydrogen, the range, payload, et cetera, is needed. So then, kind of to dive in on, the very, very local uses for renewable hydrogen, the Arches Hydrogen Hub submission to the DOE, there is a component for East Bay, both production projects, and we actually are the only production project in the East Bay area that's in that application, but also demand projects. So providing grant funding for infrastructure and vehicle purchases. So there's definitely a component of the East Bay in the statewide hydrogen hub. Heavy duty trucks, I want to highlight the Port of Oakland and Hyundai's 30 truck batch or chunk that's headed there, which is really the first sizable fleet in the East Bay area. So that's promising. That's quite encouraging. Transit buses, we have AC Transit here, has been a leader for years, but also East County, Tri-Delta Transit has won some grant funding to support infrastructure build out, but they've also committed to purchase 30 hydrogen buses. So, both East and West County will have hydrogen buses on the roads. And then the 4 refineries, of which 2 will now be producing renewable fuels, there's a great opportunity to decarbonize their existing hydrogen usage as well. And that for renewable diesel or sustainable aviation fuel products, that gets those products closer to being at net zero. So then this is a bit of an overview for our project in Pittsburgh, which is the first project we're developing. We also have another project that'll soon enter permitting, also in the county, a little bit further west in the county, but Pittsburgh's our our first project. It's in on the eastern side of Pittsburgh, an existing industrial owned area. I'd call it a medium scale project. It's 12 acres, 15 tons of hydrogen per day, a little less than $200 million project, but it's the size that fits where the renewable hydrogen market, where the demand's at today. We're in an EIR permitting process for that, also in a process with the Air District. In a success case, if all goes well, we'll be online in the second half of 2025. We're the only production project in the East Bay area that's in the hydrogen hub that was selected by Arches, so we're quite excited about that. There are other projects in the East Bay area within the hub, but they're on the demand side, so they're not producing hydrogen, but they'll be providing grants to encourage the use of vehicle transitions to hydrogen. Our waste supply will come from Bay Area transfer stations, and it would otherwise be headed to Bay Area landfill. So there's a nice, local methane avoidance there. And then our offtake, our sales of the product will be to the local, and let's call it more the regional East Bay hydrogen filling station and truck fleet market, and some potential volumes to transit agencies. I can move through this pretty quick, but this is our technology partner's last demonstration facility. We're a little bit larger than this, but less than 2 times larger. So that company and their investors have invested quite a bit in developing and scaling up this technology. And then Bechtel will be our EPC contractor, and we've committed to a project labor agreement for construction. So Bechtel is a well-known, experienced construction firm, done a lot of projects in the Bay Area and even in Pittsburgh, and we'll be using local Contra Costa Building Trades labor to build these facilities. And then this is a rundown of some of the economic development and climate benefits. $170 million facility plus or minus, and of course that increases the local Pittsburgh tax base. About 30 permanent jobs plus or minus. So as mentioned, we're a medium scale facility, but these are skilled jobs that could come from refinery or chemical plant workforce. So it's a nice job transition opportunity within the county, and then significantly more construction jobs, as might imagine. We'll produce enough fuel for roughly 600 to 800 semi trucks, just to get a perspective, and then not an insignificant amount of CO2 reduction, equivalent to roughly 20% of Pittsburgh's greenhouse gas emissions, and that's a quite industrialized city. And something else, it's besides being zero emission, hydrogen trucks and buses are also low noise. It's there's not an engine with a combustion process, so it's fuel cells, so zero emission, but also low noise. And that's it. Yeah, I appreciate the opportunity, and welcome any questions.
Thank you for that presentation, Taylor. If you wouldn't mind stopping to share your screen, perfect. That way we can see you. There were a few questions in the chat, but I'm going to just kind of go back to one of the questions we asked Tomi, which is just how does water interact with this process, or what are your water needs? Sure.
We do have a cooling water requirement, but that can be lower purity waters, reclaimed waters. Water is not a feedstock, right? So electrolysis water is the source of the hydrogen atom. So we have a quite nominal water usage, similar to a medium scale industrial facility that has a cooling water demand and some other limited process water needs.
Okay, that makes sense. Well, we like to talk about recycled water around here. This is a question from Alan. He says, can you describe your heat balance more fully? You mentioned not a combustion process, but all electric heating sounds more expensive than partial combustion.
Sure. Happy to dive deeper in that maybe directly, Alan. We have a 3-stage conversion process, and to understand that more fully kind of requires a bit of a deeper technology dive. But I would just say, sort of at a high level, if you think about a water molecule, the bonds between oxygen and hydrogen are polar bonds. They're very, very strong bonds. to break those bonds, requires a lot of energy input. Organic bonds are much weaker, right? So just basics of breaking organic bonds versus polar, it's a lot less of an energy input. We do require I'd call it a de minimis amount of natural gas for startup, as you might imagine. So there is a need for gas and heat to get the process started.
That makes sense. Alan did put his email in the chat in case you wanted to engage and kind of continue that conversation.
Okay.
I appreciate the response. And this is a question for Tomi and Taylor, kind of going back to that question that I had said that we'd get back to around biogas and biomass. So Jackie had asked, can you speak to the production of hydrogen from biogas?
Sure, I'm happy to, and then Tomi can jump in if she'd like. So I would definitely distinguish between biomass versus biogas, right? So biogas is methane. It has a biological source, whether it was tapped from a landfill or dairy manure. But biogas can be run through a steam methane reformer and an SMR, like the large scale plants that Air Products has in the States. So biogas is a different methane sourced feedstock, but it's still methane and it runs through an SMR. Biomass, which we're using organic waste, but it's biomass, right? It's an organic material. That can be used in processes like ours, and there's some others. There's some other types, but there's a couple different. But it's a solid feedstock. It needs to be converted in a different way than an SMR. So different feedstocks, but I think net whether it's biogas or biomass, the carbon intensity reduction is real. It's something that's measured, validated by CARB and the LCFS program. So there's very clear guidance on the value of biomass or biogas as feedstock. Not infinitely plentiful. That's the challenge, but we think of it as low-hanging fruit.
Thank you. Tomi, did you want to chime in there, or do you feel like that?
No, I would just offer that I can only speak to biogas, but the facility that we're working with takes animal fat or fats, oils, and greases and converts that to sustainable aviation fuel. So what we'll be doing is pulling some of the biogas off that process to change out from natural gas in our SMR. So it's just a feedstock change from natural gas to a biogas produced from animal fat, basically.
We've talked a little bit about that locally, so that makes sense. Thank you, Tomi. And then Lynn McGuire, thanks for being here, asked, what are the air emissions profiles of an H-cycle conversion facility, Taylor?
Sure. We will be below all the Bay Area AQMD threshold of significance and PST triggers. So that's a firm sort of guiding principle for us. We're in a process with the Bay Area right now, so we'll be quote unquote minor source. We do have some air emissions. We do have some NOx, some PM. When you look at conversion from diesel trucks to fuel cell trucks or from SMR hydrogen to our product, we think it's a good trade. We do think that there's more reduction in criteria air pollutants from these conversions than actually what we produce, and we're confident we will be quote unquote minor source, but we do have a small amount of air emissions. We do, which is why we should also be, and we are siting in industrial areas.
Thank you, Taylor. Lynn, did that answer your question? I saw you came off camera, so I just wanted to acknowledge in case you wanted to add to that. Okay, wonderful. Thank you. I'm cognizant of time, and I do want to make sure we have time to go through Ryan's presentation. There are a few more questions in the chat, and I'll do my best to get to those towards the end, but I just want to make sure we have some time for Ryan's presentation. Tomi and Taylor, if either of you have time or interest, feel free to maybe engage in the chat as well. But thank you for the presentation. And I'm going to hand it over to Ryan, but before I do, I'm going to introduce him. Hi, Ryan. Thank you for being here. Ryan is actually the chair of our transportation task force here at the East Bay Leadership Council. So if you ever want to come spend some quality time with me and Ryan, Tuesdays on the 2nd of the month is the time that we hold our transportation task force, and we talk a lot about issues that we're talking about right here today, which is really great. Ryan Lau is an external affairs representative at AC Transit and chair of the East Bay Leadership Council's Transportation Task Force. He's the lead on zero emission technologies for the Legislative Affairs and Community Relations Department at AC Transit. And I'm going to run the slides for Ryan, but Ryan, why don't you go ahead and say hello?
Good morning, everybody. Thank you, Lindy. Appreciate you having me. Mixing it up a little bit this morning, doing some cross-pollinization. So that I would join the Water, Energy, and Environment Committee this morning. So you can go to the second slide. That's just sort of thank you. So just as a way of introduction, AC Transit was established in 1960. We're the largest public bus-only transit system in California. We're relatively large. We cover 364 square miles, spanning 13 cities, 8 unincorporated areas, in which 1.5 million people reside. We have a fleet of 640 buses, 6 facilities, including 4 operating divisions where we, actually deploy buses. A central maintenance facility where we do all of our major repairs like engine rebuilds, transmission rebuilds, major body work, that sort of thing. And then our general offices where, all the paper jockeys work out of. Next slide, please. So we began our zero emission program in the year 2000. And have implemented one of the most comprehensive zero emission programs in the nation. We started off exclusively with fuel cell. It was a time where CARB basically asked all California public transit agencies to either go to an alternative fuel like CNG, LNG, or do a demonstration project. We opted for the more complicated option, which was to move into a new technology when nobody else was doing it. So so that's where we ended up here. Next slide, please. So we have 37 zero emission buses, 30 of which are fuel cell, 7 are battery electric, and we actually have 21 more battery electrics that I believe we have accepted all of them. But as you may be familiar, PG&E has been a little bit challenging to get transformers delivered and that sort of thing. So we're waiting on the infrastructure side of that piece in order to actually deploy them. And so in the course of our zero emission program, we've clocked in 6 million zero emission miles, 14,000 metric tons have been basically diverted. And we're actually in the process of upgrading our Oakland hydrogen fueling infrastructure. It's a fully funded project, and we're supposed to break ground next year, which would dramatically improve the throughput from 13 buses per fueling window to 70. So that's pretty dramatic. Next slide, please. As you can see, we've achieved quite a bit through our years in zero emission. Most notably, we've deployed 4 generations of fuel cell buses, again clocking in 6 million zero emission miles. And we've exceeded the Federal Transit Administration and Department of Energy targets. Several of our fuel cells have surpassed the sort of, they call it the ultimate target of 25,000 hours, one actually reaching 35,000 hours. And just as sort of an anecdote, our chief operating officer mentions this because he was around when they were first bringing the program off the ground. Because it was a brand new technology that they were sort of barely getting into the sort of commercial side of things, they only guaranteed a fuel cell at the time to operate 4,000 hours. So you can see what kind of achievement that actually is. Next slide, please. As I mentioned, we recently introduced battery electric buses to our fleet. which afforded us a really unique opportunity. So we began operating both zero emission technologies on the same routes in the same service conditions, both propulsion systems actually being in the same model bus by the same manufacturer. So it was really a truly apples to apples comparison. Ultimately, we decided to introduce some of the more conventional technologies as a control group. So we introduced 5 diesel buses, 5 hybrid diesel electric buses, and then 5 legacy fuel cell buses, which are sort of like the previous generation, and then 5 battery electric and 5 contemporary fuel cell, which colloquially we call the 5x5 study because there's 5 technologies and 5 buses each. And so the study is actually validated by Stanford's Precor Institute for Energy. Personally, I take offense to that since I'm a Cal graduate, but you know, I don't control those things. So by the time we actually finished the study, we ended up incorporating all of our learnings into what we now refer to as the zero emission transit bus technology analysis. Sorry, that's a mouthful. Which basically it evolved past just being a mere comparison and really has become a roadmap for fleets that are just sort of taking off on their zero emission journey. It distilled down a number of different things that are important to sort of really understand what a zero emission program requires. And that's, you know, operating cost, vehicle reliability, charging and fueling facilities, data infrastructure, workforce development, and the list goes on. One of the clear differences between battery electric and a fuel cell bus, as Tomi rightly noted, you know, CNG vehicles, CNG, so compressed natural gas and liquid natural gas buses operate all over the state. And so converting those fleets to hydrogen actually requires virtually no changes to your operation. It functions almost exactly the same. You pull up your bus to the fuel island, you lock in the fueling nozzle, fuel up in 5 to 10 minutes, and you keep the whole operation moving. Next slide, please. So we also have our zero emission transition plan, which is basically a roadmap for how we're going to move to fully zero emission. And you know, the California Air Resources Board has been a leader in regulation around this, and we have our own regulations. So as was mentioned, there's advanced clean fleets and the like that regulate sort of trucks and that sort of thing. But public transit has its own rule, the innovative clean transit regulation, which requires all public transit agencies to transition their fleets to 100% zero emission by 2040. And the way that each agency reaches that goal will depend on their service environment, route conditions, infrastructure availability, et cetera. Our zero emission transition plan calls for 70% fuel cell electric buses and 30% battery electric buses. And just so that you understand the magnitude of what that full transition will take, we did an analysis of what we expect it to cost. And just for our transit agency alone, we're looking at $1.3 billion. So that's infrastructure and buses together, but that's a pretty hefty number for one transit agency. And some of you may know that in the Bay Area, we have 26, 27 transit agencies. So Bay Area alone is probably going to be a considerable number. In addition to that transition, we also have a board adopted Clean Corridors plan, which is the first plan to tie equity to zero emission deployments, which basically means that any investment in zero emission technologies actually directly benefits those communities that have historically suffered from poor air quality and really needed the most. Next slide, please. And as a leader in zero emission transportation, we felt like it was necessary to not only show other people how to make the transition, but actually pave the way as well. So in the 2021-2022 legislative session, we sponsored a bill that exempts public transit agencies from paying state sales tax on the purchase of any zero emission bus, which obviously is a big incentive. And we also recently were awarded a $25.5 million federal Lono grant to upgrade our training and education center. Next slide, please. And our training and education center goes back to something I referenced earlier, which is workforce, and that's something that I think is maybe not always considered when people think about the transition from sort of a diesel or CNG slash LNG fleet. You really have to have the workforce that can work on those vehicles, and so we would basically take our really aged training and education center and create a brand new advanced learning lab. It would utilize augmented reality to work on high voltage systems safely. As you can imagine, you can't just jump in and start playing with wires when you're talking about kilowatts of energy. Otherwise, some pretty disastrous things can happen. So augmented reality also allows our trainers to train all over the country and all over the world without actually having the trainer in the same room. So it actually leverages our ability to take this group of really talented trainers and be able to share their talent across our service area, but also to other agencies in the state or across the country. So we're really excited about that. Let's see. The other thing that we really want to incorporate in this new advanced learning lab is career pathway. So we envision working with community-based organizations and academic institutions to recruit and teach people from our own communities. So as I mentioned earlier, we have a considerable amount of disadvantaged communities in our service area, and so we feel like it's important to kind of give back to the people that reside in our service area. And the other thing that this $25.5 million Lono grant pays for is 25 new hydrogen fuel cell vehicles, which will obviously bring us closer to full fleet conversion. As an agency, we've done a lot in the way of paving our way to zero emission technologies, and we really want to press on and share our learnings and be a resource to the industry. Next slide, please. And so that's all from me. If you want to get a hold of me, there's my email address, and that QR code, I think, brings you to our zero emission website, which basically has our transition plan, the zero emission transit bus technology analysis, and virtually all the other documents related to our zero emission program. So happy to entertain any questions if there are any.
Thank you, Ryan. That was a wonderful presentation. There's definitely a little bit of Cal-Stanford rivalry happening in the chat, but I think the important thing is you both have wonderful degrees from wonderful local institutions that we're very proud of. So that was definitely fun to read. Other than that, I think the main question that came out of that presentation, Ryan, was a little curiosity about the 5x5 comparison. Is the results of that something that you all have made public, or is it still being analyzed?
Yeah, they are public. So it was a 2-year study. We did it in sort of 6-month chunks and shared our learnings every 6 months. And now we're going to be doing an annual report. I will say that each technology has its own benefit. I will allow you to sort of make your own assessment. We have a board that has varying preferences on technology, so I'm not gonna say there's a clear winner. But hydrogen definitely does have its advantages. Some of that may be that we have 20 years of experience in that technology, so we're a lot more comfortable. And so all of those studies are on our website. You can take a look at them and sort of make your own make your own assessment.
Okay, will do, Ryan. Thank you. And then someone had asked in the chat just about whether you're comfortable sharing slides. Or are you
Oh
comfortable?
yeah, absolutely.
Or would you be comfortable if anyone requested? Wonderful. Okay, I'm happy to make those connections if needed. And then just out of curiosity, Ryan, where does the hydrogen you all use come from?
So one of the things that I think Taylor and Tommy will agree is that hydrogen is still maybe not nascent, but it's not fully commercialized the way that we would like to, which is why I think it's important that those two production companies are here representing us. So we're actually getting our hydrogen from Southern California. And we would really love to have local production facilities where we can source it locally and sort of avoid that carbon cost to transporting that fuel across the state. So,
okay, that makes sense. Alan also asked, what do you think about solid state batteries? And, would those kind of shift or impact the advantages?
I am not part of our technical side of the team. I'm the talking head that they bring out to these things that can sort of talk in lay people's terms. I know virtually nothing about solid state batteries, so I apologize for that. I can look into that more and contact you at your Stanford email address.
I actually think that might be a great topic for this task force. So I'm going to say to Dan and Gary and George and all of our leadership here that maybe that's something we bring up as a future topic, is to dive a little bit into that. We have had presentations on batteries before, but specifically solid state. Tommy was curious, Ryan, do routes determine which bus you guys utilize?
Yeah, I mean, so when you get to a certain type of mileage for a route, you definitely have to move to hydrogen. Depending on the manufacturer and other factors that are involved, battery electrics can run 150 to 200 miles. Hydrogen are like 300 plus. And so you do get some benefit in terms of range out of using a fuel cell bus. But you basically have a ceiling when it comes to battery electric, just because as soon as you get to a particular range, you don't want it to sort of limp along at the last leg of the trip. And as soon as you get to a certain state of charge, then you have to hang it up for 5 hours to re-energize the battery. So yes, it is informed by the routes.
Thank you, Ryan. I believe, oh, look, there might be one question that just popped up. Oh, folks are interested in slides. So I think that just shows how engaged everyone is in this topic. And I really appreciate the three of you being here. We did have one more question that we weren't able to get to before for you, Taylor, and I think I'm going to go back to that. Give me 1 second. So Bob Brown, do you want to ask the question yourself, Bob, or would you like me to? I just saw that you came on camera.
No, go ahead.
Okay, so Bob had asked, the power to convert the solid waste to H2 has to come from somewhere. Since there's no combustion, is it from a fair amount of electricity?
It is from electricity, but we would say it's not necessarily a fair amount. So
Okay.
we use roughly 12 kilowatt hours per kilogram, so 12 kilowatt hours in, kilogram of hydrogen out. Electrolysis is in the 50 to maybe up to 55 range. So we do use electricity significantly less than electrolysis. But yeah, that's our energy input.
Thank you, Taylor. Okay, I hope that I've gotten to all the questions in the chat. There was a lot coming out throughout the presentation, so apologies if I missed one. If I did, please feel free to email me and I'd be happy to shepherd your question to any of our presenters, Ryan, Tommy, and Taylor. It's really been wonderful to have you here today, and I appreciate all of our presenters coming and joining us and informing us. It's really exciting to have this work being done right here in the East Bay, and exciting to have a space for us to talk about it. So thank you to the leadership team who helped to put this together. And I want to have a quick shout out to Meg Stern, staff at the East Bay Leadership Council, who helped to organize this. She did a fantastic job bringing this panel together. So thank you, Meg, and thank you, Tommy, Taylor, and Ryan.